Lesson 3. Maximum or minimum of a quadratic function. A quadratic function can be expressed in standard form, in factored form, or in vertex form. In standard form, we have f of x equals ax squared plus bx plus c, and c is the y-intercept. So when a quadratic is in standard form, it has the format f of x equals ax squared plus bx plus c, with c being the y-intercept. You can verify this by substituting x equals 0 into the function. We know from grade 10 that when x equals 0, we have a y-intercept. So to determine the y-intercept of this form, we substitute 0 for x. So f of 0 equals a times 0 squared plus b times 0 plus c. 0 squared is 0. 0 times b is 0 plus c. 0 times a is 0. 0 plus 0 is 0 plus c is c. So we know that c is the y-intercept for this form of quadratic equation. In factored form, f of x equals a times x minus r times x minus s, and the x-intercepts are r and s. So in factored form, the quadratic equation has this form: f of x equals a times x minus r times x minus s, with the x-intercepts being r and s. Not negative r, not negative s, positive r, and positive s. Note this is a subtraction: x minus r, x minus s. In vertex form, f of x equals a times x minus h squared plus k. The vertex is hk. So in vertex form, the quadratic equation takes the form f of x equals a times x minus h squared plus k, with the vertex being positive h, positive k. Note that this is a subtraction, so we have the vertex is positive h, positive k, hk. The sign of the coefficient a in these functions dictates the direction of opening of the parabola. So the sign a in all of these cases dictates in what direction the parabola opens. A. If a is greater than 0, the parabola opens upward and the vertex is a minimum. So we have an example here. F of x equals ax squared with a greater than 0. So if a is greater than 0, the parabola opens upward and the vertex is a minimum. The vertex is a minimum. 0, 0. So whenever a is greater than 0, you can remember that the parabola opens upward, and then you will remember that we have a minimum. This holds true with the minimum and the parabola opening upward for all of these cases when a is positive. If a is negative, the parabola opens downward and the vertex is a maximum. If a is negative, like in this case, f of x equals ax squared, with a being negative, the parabola opens downward and the vertex is a maximum. The parabola opens downward and the vertex is a maximum. You can remember always that when a is negative in these cases, the parabola will open downward, and then you will remember that it has a maximum. And again, this applies for all cases for a in all of these equations. If a is negative in this equation, or in this equation, or in this equation, then the parabola opens downward and the function has a maximum. In order to determine the vertex of a quadratic function, it must be expressed in vertex form. So in order to find the vertex of a quadratic function, it has to be in vertex form. If you are given a quadratic equation in factored form, convert it to standard form by simplifying. So that's the first step if you have an equation in quadratic form. You have to convert it to standard form. Once in standard form, you must convert the function to vertex form through a process known as completing a square. So then, when it's in standard form, you have to complete the square to get it to vertex form in order to find the vertex. Let's go through an example. F of x equals 2x squared plus 12x plus 7. And again, this is in standard form, where f of x equals ax squared plus bx plus c. A is 2, b is 12, c is 7. First, ensure that the x squared term has no coefficient. If it does, factor it from the first two terms. So the first step we do is make sure the x squared term has no coefficient. It does here. It's 2. So we have to factor it from the first two terms. So in order to do that, we put this in brackets, 2x squared plus 12x, and we factor out the 2. We get 2 times x squared plus 6x. Because 2 times x squared is 2x squared, and 2 times 6x is 12x. Plus 7. The plus 7 comes along for the ride. We don't factor anything from the plus 7, just from the first two terms. Then divide the coefficient of the x term by 2. The x term is 6. Divide by 2, so we get 3. Square it. 6 divided by 2 is 3. 3 squared is 9. And add it to the x term to make a perfect square trinomial. So we're going to add it to the x term, to 6x, to make a perfect square trinomial. So we're going to add 9 to 6x. Then subtract the same term so that the value of the function remains the same. Adding and subtracting a number does not change the value of an equation. So here we're going to do plus 9 minus 9. So as we can see here, this is what we did here. We took 6 divided by 2. We took the x coefficient. We divided it by 2. We got 3. When we squared it, we got 9. 3 squared is 9. So then we added to the trinomial, and we subtracted 9, because when you add and subtract a number, it doesn't change the value of an equation. Note that we kept everything in brackets because it's part of the perfect, because the 9 is part of the perfect square trinomial, and the negative 9 is being subtracted from the 9. So we keep this in brackets. Now you must remove the constant you subtracted, so that you are left with a perfect square trinomial in the bracket. So now we're going to remove the negative 9 that we subtracted. So you're left just with the perfect square trinomial. X squared plus 6x plus 9. To do this, multiply the negative constant with the value in front of the brackets. 2 in this case. Then add this to the constant term after the bracket. So we're going to multiply the negative constant with the value in front of the brackets. Then we're going to add this to the constant term after the bracket. So we do negative 9 times 2 is negative 18, and we put it outside the brackets. Note that when we're removing everything from inside the brackets, it's being acted on by the factor of 2, because this is multiplication. So we have to multiply negative 9 times 2. We get negative 18. Then we add with what's left outside of the brackets. Negative 18 plus 7 is negative 11. So finally we factor the perfect square trinomial. This is the perfect square trinomial. To factor it, we take the square root of the first term, x squared, we get x. And then we add or subtract depending on what the sign is. If it's addition, we add. If it's subtraction, we subtract. So it's addition, so we add x plus. and then we take the square root of the last term, the constant term. The square root of 9 is 3. So we have 2 times x plus 3 squared, because that's the next step that we do. We square the square root of the first term plus or minus the square root of the constant. And we get x plus 3 squared. So it's 2 times x plus 3 squared minus 11. Note that this is in the form f of x equals a times x minus h squared plus k. This is in vertex form. So now we can find the vertex. Therefore the vertex is negative 3, negative 11. Notice that there's a subtraction sign in front of the h. Here there's no subtraction sign in front of the h. But there has to be a subtraction sign for it to be in this form. So we subtract the negative, because subtracting the negative is the same as adding the positive. So we do x minus negative 3. And so the the value of h is negative 3. Similarly, the value of k is negative 11. It's just a plus sign there. So whatever the value of k is here, we have to take into account the value of the sign in front, because this is the value of the constant term. It's the value of k. Not the value of negative k, but the value of positive k. So we have to just take this sign in front and keep it. So we have negative 11. But for the h we have to do the opposite sign, because it's x minus h. So instead of it being positive 3, it's negative 3. Another way of finding the vertex of a quadratic equation is to use partial factoring to find the x-intercepts. So another way we can find the vertex of a quadratic equation is by using partial factoring to find the x-intercepts. The vertex can then be found. The vertex is on the line of symmetry of a quadratic function, or halfway between the x-intercepts. So, because the vertex is on the line of symmetry of a quadratic function, halfway between the x-intercepts, we can use the x-intercepts to find the vertex by finding the midpoint of the x-intercepts. That's because it's halfway. That's because the vertex is halfway between the x-intercepts. Since the third term only affects the vertical position of a parabola, we only need to factor the first 2 terms. So to find the x-intercepts of a quadratic equation in standard form, you only need to factor the first 2 terms, because the third term is c. ax squared plus bx plus c. The third term is c. So it only translates the function up or down vertically. So we only need to factor the first 2 terms. Let's look at an example. Suppose we wanted to find the vertex of the following quadratic equation. Y equals 6x squared minus 12x plus 5. In order to find the x-intercepts, we must factor the first 2 terms. So that's because, again, only the first 2 terms affect the x-intercepts. The third term is c, which is a vertical translation. So in order to find the x-intercepts, so now let's find the x-intercepts now. So we start by factoring the first 2 terms. We remove the plus 5 because that's the constant term c, and that's not needed. 6x squared minus 12x. We factor that. We take the greatest common factor, which is 6x. How do we know that? 6 and 12. What's the greatest common factor of those two? 6. X squared and x. X is the greatest common factor. So 6x is the greatest common factor. 6x squared divided by 6x is x. Negative 12x divided by 6x is negative 2. So now we solve for the x-intercepts. Now we determine the x-intercepts by letting y equal 0 after we factored the first 2 terms. So y equals 0, let y equals 0. Then you remember how to solve this equation from previous grades. 6x equals 0 or x minus 2 equals 0. X equals 0 or x equals 2. Next, find the average of the two x-intercepts to give you the x-coordinate of the vertex for y equals 6x squared minus 12x plus 5. So next we're going to find the average of the two x-intercepts to find the x-coordinate of the vertex. Note that we will use the original equation to find the vertex, y equals 6x squared minus 12x plus 5. This is the quadratics equation. So here we take the average of the x-coordinates. 0 plus 2 divided by 2 is 2 divided by 2 equals 1. The x-coordinate of the vertex is 1. To find the y-coordinate of the vertex of the quadratic equation, y equals 6x squared minus 12x plus 5, simply substitute x equals 1 into the equation. So when we substitute x equals 1 into the equation to get the y-coordinate of the vertex, we get 1 squared is 1. Negative 12 times 1 is negative 12. 6 times 1 is 6. 6 minus 12 is negative 6 plus 5 is negative 1. Therefore, the vertex of the function y equals 6x squared minus 12x plus 5 is located at 1, negative 1. Using one of the methods listed previously, solving a word problem involving a minimum or maximum is fairly simple. First, identify what the problem is asking. Write a quadratic function if necessary and find its vertex. Remember to conclude with an answer statement. Let's look at a word problem. So the steps when solving a word problem are identifying what the problem is asking, writing a quadratic function if needed, and finding its vertex. Then we conclude with an answer statement. There is two ways to find the vertex. We can either complete the square or we can factor the first two terms. Let's continue by looking at the word problem. Rahim and Sanjeet create jewelry each summer for a local fair. Last summer they sold 100 pieces of jewelry at $15 each. They know that for each $1 increase in price, they will sell 5 fewer pieces of jewelry. What price will maximize revenue? So we know we're going to be modeling revenue, and we're going to be modeling the number of $1 increases. And with the baseline figures are going to be 100 pieces of jewelry at $15 each. So revenue is equal to price per jewelry times number sold. So we're going to be doing a quadratic function, modeling the revenue, and we're going to be using the baseline numbers of 15 times 100 pieces of jewelry. First, write a let statement and create a quadratic equation to represent the situation. So we write the let statement. Let x represent the number of $1 changes, and let y represent the revenue in dollars. So x is going to be the number of $1 changes, and we're modeling y as a function of x, where y is the revenue in dollars. So revenue we know is price per jewelry, which with the baseline being $15 times number sold, with the baseline being 100. So we do y equals 15 plus x, first price per jewelry, 15 plus the number of $1 increases. So 15 plus 1x, 15 plus x, times 100 minus 5x, because we do times 100 pieces of jewelry minus 5 fewer pieces for each $1 increase in price. So times 100 minus 5x. Then we multiply this multiplication out and simplify. We get y equals minus 5x squared plus 25x plus 1500. Then we complete the square. we factor the first two terms. We factor out -5. Then we divide by 2 and square the 5, because it's the coefficient term. We get 5 over 2 squared is 25 over 4. Notice that we add 25 over 4, and then we subtract 25 over 4. But we keep it in brackets until we remove it from the brackets here. When we remove it from the brackets, we multiply by -5. Then we complete the square here. Here we complete the square. We do 25 divided by 4. The square root of that is 5 over 2. It's a negative in front because this is the term here has a negative in front. And we take the square root of x and we square that. X minus 5 over 2 squared. Then we simplify the remaining fractions and we get our final answer. Y equals -5 times x minus 5 over 2 squared plus 1531.25. The vertex is at maximum at 5 over 2, 1531.25. As a result, 5 over 2 increases of $1 will maximize revenue. So we have 5 over 2 increases of $1, which will maximize revenue. And will make revenue $1,531.25. This is the number of increases of $1, so we multiply it by 1. 5 over 2 times 1 equals 2.5. So we know that our baseline price is $15. So we're increasing by $2.50 to $17.50. So an increase of $2.50 to $17.50 will maximize revenue. Note that the x value represents the number of $1 increases needed to maximize revenue. And that's all for lesson 3, maximum or minimum of a quadratic function. Stay tuned for lesson 4, which is working with radicals. Be sure to like and subscribe this page and click on the end cards on the page to visit the next lesson or to see more lessons in this course. Thank you.